Well, hello everyone, and thank you for coming. My name is Stefan Lupsa. I am a cloud engineer at Cloudbase Solutions, and I'm a member of the support team, where I work very closely with OpenStack and Coriolis, which is what I'll be talking about, or how to easily migrate your workload to Charmed OpenStack. So what is Coriolis? Coriolis is designed as a disaster recovery as a service and the cloud migration as a service solution. So we can either help you lift and shift your workload from, depending on what is currently supported, any cloud to any other cloud that Coriolis currently supports. And also, for the disaster recovery as a service, we have a more granular approach, about which I will discuss more detail cover, and that is what we call replicas. So Coriolis is built like an OpenStack project in the sense that it's service-oriented, and we have a conductor, a scheduler, and also communication over RabbitMQ and message queue platforms, and it integrates very easily with Keystone because it also uses Keystone for its authentication purposes. It's almost entirely built in Python and also already uses the common libraries that OpenStack itself defines and uses. Right, we also provide a client library and a REST API that's easily to consume, so you can integrate it into whatever you need and use your own automation to link up with Coriolis in order to automate the cloud migration part of it as you need to fit. And we also ship it with a fully fledged web GUI, usually at least, in the form of the appliance, where you can just deploy it and access the web interface. When we say Coriolis is pluggable, we mean that all of the cloud support comes in the form of plugins. So whenever we want to extend this, we create either a source or a destination plugin for a cloud provider. And after that is created, we can migrate to and from that particular cloud to all the other already supported clouds. So it's fully decoupled, and it's easy to get new support for a public cloud which you might be interested in. We strive to run agentless in the sense that we only use public APIs, and non-administration or non-privileged credentials are required. We will only require the most basic operations which our user is expected to be able to do. For instance, like creating resources, booting up machines. And Coriolis automates this process for each source and destination platform in order to do migrations. So as we don't really need administrative, we don't even need access to the hypervisor itself. Public covered this basically because it's a 2-in-1. Scalability. Since again it's built like an OpenStack project, you can either deploy it with one worker or up to 1,000 workers and schedule as many tasks to run in parallel as you require. And since I've mentioned it's already uses and leverages Keystone, you could also pre-integrate it with your pre-existing Keystone deployment that you might be using on your Charmed OpenStack, so that you can give cloud migration capabilities to your pre-existing users. And following Keystone's LDAP authentication plugin with user rights management as well. Now, cloud endpoints. cloud endpoints is what we specifically define as the means to connect to a pre-existing client's cloud, as we will need only user access and the API endpoint of the specific provider. These will be saved in Coriolis, and they will be saved in Barbican encrypted. And Coriolis will validate them once we have provided the details to check that they're safe to use. It will do a basic check of all of the endpoints provided to ensure that it will then be able to create migrations and replicas based on that endpoint, whether it be source or destination. So currently we support quite a wide platform of cloud platforms, including OpenStack and VMware, which is what we'll be demoing today, as well as a plethora of public clouds, so like the whole OCI and OPC and all of the Oracle suite that is private and public, as well as Azure, AWS, and I heard GCP is also in the works, but we don't have any commitment to that. In any case, since it's all plugin based, if there is a source or a destination required for any particular customer, we could, depending on the required amount that they would like to migrate from or to that destination, implement it as a part of the shipping Coriolis. So migrating and replicating Coriolis usually treats the machines like a black box in the sense that we do not peek or we treat it completely independent of any other machine. We just replicate the data, gather the metadata about the instance, store it, and recreate it on the destination. And there is also the step which we call OS morphing, in which we adapt the operating system to ensure that it boots. Because there may be different agents, there may be different drivers required for, either on the destination that might not be present, and we install them as part of OS morphing, ensure that everything is up to speed, and then we will boot the VM. However, Coriolis only minimally intrudes, so it will only install the required components in order for the machine to boot on the destination. And we support a large amount of Linux distribution, as well as most Windows servers. And even though some may be end of life, Coriolis still has code support for them. However, we do not guarantee that this may work, since this is very dependent on what the operating system provider still has available in the sense of drivers for a specific cloud or technologies such as Verteo drivers and anything like that. However, we can still migrate older Ubuntus, older Windowses, and Red Hats and the sort. Although for Red Hat it might be a bit difficult, since there's also licensing to take care of, but that's still as part of, if it's possible to get packages, we can migrate it. Now I've spoken about replicas and migrations, since these are the two modes of operation. A migration is a one-time operation that is lift and shipped. We take the instance from a source and we put it to the cloud. And that's basically it. You use it once and then you move on. When we're talking about replicas, a replica offers a bit more granular approach, in the sense that you can also use it for disaster recovery as a service, which will create a sink on the destination of your current instance on the source. And this will be able to continually sync the disk using incremental disk snapshots, transferring only the differences from the source since the last snapshot, and have it ready to deploy in case disaster strikes. However, you can also deploy it even before the disaster strikes. And we encourage our clients to test out the mode to ensure that everything is set up correctly and that they have a valid backup that can be instantly deployable. So you have a lot more granular access, and you can keep it constantly synced up. We're going to cover replicas in a bit more detail in the demo. So lift and shift. We've gone through these. All right. And when I meant that they're granular, you can separate the two. So syncing the disk from the destination and deploying it are completely independent operation. And the deployment is not dependent on the source, because of course you would want to use it in a disaster recovery scenario. You would not have a source. So talking about more in depth of how this actually works. When you create a replica, the steps are that you first create the replica, which will check the machine. We're going to those the steps. We're going to check the machine. We're going to read the configuration, what are the disks, what are the networks, how everything is configured. And we're going to start creating tasks, which will, first of all, create all the necessary source and destination resources, for instance. Usually this implies a destination machine, which we call a worker, which will attach a fresh disk, which will receive the source data. After the disk is synced, the disk is detached, and the worker and all the resources the Coriolis has spun up will be cleared out. All security groups, network ports, anything, it will clean up after itself. Very important, when we get to transfer the written chunks, we do differential snapshotting, and we only transfer the differences. In case of the first synchronization, we will only transfer the non-zero parts of the disk so that we don't needlessly use the wire for no good reason, which will ensure a higher actual throughput of the data. And after a replica is synced, you can either choose to deploy it or sync it again. And during the sync is where we would, during the deployment, is where we would get to the OS morphing step, where we would prepare the instance to finally be deployed on the destination. So Coriolis will already have backed up all of the machine's parameters. It will just query that they're still valid on the destination, and then create a worker machine, which will again attach the disk. However, in this case, the worker machine might be a Windows or Linux, and it's quite dependent because only a Windows worker can migrate to Windows machine, and only a Linux worker can migrate to Linux machine. When we were talking about syncing the disk, it's all done through a Linux worker, and that doesn't really matter as long as the kernel is fresh enough. But we generally recommend the latest Ubuntu LTS version. Now, after OS morphing, which is, in the case of an Ubuntu coming from vSphere, we'll see, uninstalling the OpenVM tools, making sure that Cloud Init is there, creating the configurations, if any are required for Cloud Init, and then that's pretty much it, because later Ubuntu's already come with virtual drivers, which it would install for Windows. You would need a virtual driver in order to boot up on OpenStack. And after everything is done, it will detach the disk, clean up the worker, and spin up the final machine with the disk that was just OS morphed. Now, now we're going to go through exactly this process. So we have our Coriolis GUI here, and we're going to log into it. And we have our two endpoints preset up. However, they're literally just credentials and configurations for connecting to OpenStack. and we're going to check that they're validated. Well, at this point, Coriolis is going to check if the endpoint is valid, reachable, if the credentials are authorized to get, and it will either give us that green tick mark which you saw, or a meaningful error of why we couldn't reach it. Okay, since both of our endpoints are okay, we're going to go ahead and migrate this machine over here from VMware, which is just a simple Ubuntu Focal, I think. There we go. Yeah, this is a Focal Ubuntu. So let's go ahead and create some test files. Okay. Not test, like. There we go. Now let's make it up top here. So let's go ahead and create a replica. And this is where we can, again, given the ability to select whether we want a replica or a migration. And for the purpose of this demo, we're going to go with a replica. We're going to select the source and are presented with source options to configure. These are dependent on each cloud provider. For vSphere, since we are going to use a CBT and leverage the mechanism of CBT snapshots, we don't really need to configure much, since we're just going to read the data directly from the ESXi host. So let me go ahead and search for our demo Ubuntu here. And Coriolis is already telling us this machine's got 2 gigabytes in a processor. And then we will select our target platform. Now, for Charmed OpenStack and OpenStack in general, these are quite a lot of configurable options. And this is mostly because OpenStack is very configurable itself. It can support many backends, many different types of networks. However, we do offer the possibility to configure this through a predefined default in the Coriolis configuration. So that when you select a new machine, you might be able to click straight through and not necessarily have to check everything being in order. Now let's see, since we didn't have the foresight, or rather didn't want to have the foresight, we're going to go through each of these. In the case of availability zone, we're going to leave Nova to decide where it wants to go. We can optionally delete this VM termination so that it cleans us up without leaving the volume behind. And we're going to use a floating IP because we would want to actually reach the machine. All right. Now, I'm going to say retain user credentials. Alternatively, I could give it a key pair from which was already defined in OpenStack, which will is the standard way we would deploy an image in OpenStack by Cloudinate and providing it with credentials. All right, I'm going to use HTTPS since this is faster. However, in some instances, it might not necessarily reach the machines, depending on firewall settings and stuff. So we offer SSH as a backup. We are migrating to a KVM, and we're going to leave the flavor empty because we can override it here, but Coriolis would do its best in finding the optimal flavor based on the source machine specifications. Okay, and giving some SSH and ping ability to our machine, and that's about it for that. Now we reach our temporary migration worker, where we're going to tell it to use the admin net and make it a medium and a floating IP pool of external subnet. And tell it that, yes, I also would want to use floating IP so the Coriolis can reach the worker, because in this case, this Coriolis is not actually deployed on the destination. And we're going to use the Jammy image as our migration worker. All right.
So what is OL? Linux Jammy and
Sorry?
there is there is a drawdown list, and there are several options.
This is where Coriolis reads up the images defined in your OpenStack.
Oh, okay.
So we're just going to use Ubuntu Jammy as the migration worker.
There is, I know Jammy, I know OpenStack, but what is OL?
It's a shorthand for Oracle Linux.
Oh, okay.
All right. Well, this the name is basically whatever the user that created in the image. So, all right. And then we're going to click next. We'll select the test private network and move on. Actually, this is a one NIC instance. So if we'd have more than one NIC, Coriolis would give us the possibility to map all of the networks. So it's detected that it's coming from VM network on the source. Over here, if you look, like our VM network adapter is connected to VM network, and it's giving us the details over here, and it's listing all of the networks that it's detected that we have access to on the OpenStack side. So we can tell it, okay, you are taking this network interface and mapping to this, and so on. When we get to storage, we have a few more granularity, because since various cloud providers can have multiple data stores, multiple backends for disks, you have the possibility to either select a default storage, which is a disk type in OpenStack over here, which Coriolis detected for us, or map a whole data store to another backend in case you are using multiple, or you can use per disk mapping individually in case you might have, I don't know, an SQL server and you have your database mounted somewhere on a disk. You can map that disk to an NVMe drive if you have that option, so that you have much faster database access. Okay. When it comes to user scripts, we can optionally configure them for shorthand actions, anything that's the user might want to change in the machine specifically, so that they might want to prep to run in a specific way after migration, or some things are required. We give the option to either for Windows write any script in PowerShell, or for Linux in pretty much any shell that the worker image supports, with the only requirement that the script's single parameter is the disk where the Coriolis will mount the machine being OS morphed. And all of these, if a user would choose to use a user script, will get executed before Coriolis installs or removes any packages. All right. Right at the end over here, before we get to the summary, we have the possibility to create a schedule. This is a cron-like schedule. So currently, this is going to run at 12 o'clock, if I leave it like this, 12 a.m. every day. Or I could tell it to run at each minute or 12 a.m. Or simply go every minute as fast as you can. Like when a replica ends, the next minute it will create a replica again. But we won't go into this, as we don't really have the time allotted. And we're presented with the summary, which details all the choices we made and all the options we configured for Coriolis to migrate this machine. And we're going to go finish. Now, Coriolis is going to create a couple of tasks over here. So it's going to validate the source and replica to make sure that they're consistent and that the options we've selected are valid and that they make sense for creating the replica. Oh no! Looks like something went wrong. As I've actually used the admin net for the worker VM, there is no router in OpenStack predefined, so Coriolis correctly identified this and is telling me much faster than it would take to sync the whole disk and then actually fail at the point that I need it to work. So these three tasks, the validate, source, and input, they are basically there to filter out any inconsistencies in the configurations. So to ensure that once you start syncing, everything should be fine. But this is okay because we can go ahead and to the target options and remap the worker machine and update the replica, at which point Coriolis will get the database right. And now we can simply execute this again. So it's going through specific changes and anything that might require or make the deployment fail. So we've selected a lot of things for the OpenStack, so Coriolis went ahead and checked that to make sure that the worker flavor is consistent, we can use it, the network exists, it can reach the floating IP that we can, or the floating IP can be mapped to the machine after it's booted, and stuff like this. All right, so it's going to deploy the disk, as you can see over here, and in this case of VMware, there are no required resources on the source, so we just skipped that, it didn't create anything. And we got to deploying the target resources. This is going to create a keeper, which is going to use to boot an instance. And this is going to be based on the Jammy image that's in OpenStack and we've selected. A code tree. What? So, apparently, something is actually wrong. I must have selected the wrong flavor for migration.
It has no flavor. I think we turned and used one with 0.
Yeah, because that was the flavor created for them. It's okay. I'll cancel and edit it because I must have went through these really fast and not selected the flavor for the machine. However, I think I did, but not during the edit.
The flavor of the target for the worker.
For the worker, yeah. But is the flavor test project demo flavor? Yeah, it's automatically selected demo flavor when I wanted M1 medium. No, I think that was actually my bad, and I just skipped through it fast. The demo flavor was created in the OpenStack target destination just because it perfectly matches the source destination, the source machine specs. So we would have wanted to, and we will see this because Coriolis will actually choose it, even though we haven't configured it for the, we've configured the migration flavor name over here as mem1 medium, which is for the worker machine. And it hasn't actually retained any configuration for the end machine. So in this case, it's going to use which image it best, which flavor it best, finds that it best fits the source machine.
Is this OpenStack Charmed maintained by your team or by Canonical?
This particular Charmed OpenStack is just a deployment in our data center.
Oh no, I mean the Charmed itself, not the bare methods.
I'm sorry? No.
Is the OpenStack a Charmed? It is or not?
So the Charmed OpenStack, the charms are maintained by Canonical to my...
Okay, yeah. And my second question will be, so do you have a partnership with Canonical or just simply use their Charm on Charm Hub?
For Coriolis, sorry.
I mean, Canonical maintain the Charm, the OpenStack Charm, right?
Yeah.
So are you simply a user of the Charm? Are
Um,
you a part?
OpenStack in itself, it's a private cloud.
yeah.
Okay.
That is provided and maintained. The charms are built and maintained mainly by Canonical.
Okay.
So in this case, Coriolis is a separate project or entity. And it just can migrate to OpenStack or Charmed OpenStack.
Okay.
Actually, we didn't sign into this.
Okay, I got it. Yeah.
Now we can see over here in the instances that we have a worker, which is just finished booting, and Coriolis can talk to it. And once it's established communication, it configured the writer and is going to replicate the disks, which involves creating a CBT snapshot of the source machine and transferring the data. And since this machine isn't particularly big, as you can see, the total size is 8.5 gigabytes of the disk, and only roughly 5.6 are written. Only that 5.6 gigabytes are going to be transferred to the destination. And it should be done quite fast now, since it's not a really big machine. But this, in any case, Coriolis is going to transfer as much as it can, and this is only dependent on the network throughput and the capabilities of the source and destination clouds of receiving the data. So Coriolis doesn't slow it. It is always going to use as much resources as it can get to get it done as fast as possible.
Would you mind clicking the fourth tab?
Yeah, so this is the worker, this is the Charmed OpenStack, this is the destination. And
So this in this OpenStack is maintained by Canonical. Am I right?
this is on old, well, the charms, yes, but this is deployed in our private cloud.
Okay, deployed by you in a private cloud.
Yeah.
Okay.
So the OpenStack and the charms, they're open source.
Yeah, I know.
So this is just deployed on our hardware. And we're using it as a destination for this particular demo. And we can see that Coriolis is already removing the snapshot because it's finished transferring the disk. And it's proceeded to clean up after itself. Now, we double check. You can see the instance is gone. Only our key pair remains. And the replica sync is finished. Now we can create a migration from it. And we're going to clone the disks. This gives us the option to clone the disk so that we can keep syncing to the original replica, which is not images, this volume over here. So we can additionally clone it and keep syncing to that without compromising its integrity by booting the disk. And in this way, we're going to migrate this to double check that everything works. And we know that we still have the replica state saved, to which we can keep executing replicas. And over here, we had a pop-up that was telling us that a new migration task was created. And we can check, and we go to migrations. We have it here. We can see that it's from this replica that we've just executed. And Coriolis has already started. It checked the snapshots that exist, validated the deployment, and started creating the target migration worker. Now I can double check. We have another volume, which was created from this one. And after it gets connectivity to the migration worker instance, it's going to attach it, as we can see here. And if refresh OpenStack, it's going to say, there we go, it's attached to this worker machine. Now, Coriolis is going to connect to SSH and execute all the required steps, which in this case are uninstalling OpenVM tools and installing and configuring Cloudinit for the destination. Depending on what the source and destination are, it might additionally install or uninstall drivers, and rebuilding init ramfs for the current kernel on the destination. And we see it over here, it just finished. And after it detected that this is an Ubuntu 20.04, it removed the old agent and tools. It reinstalled Cloudinit. And then it finished, after it finished installing, it demounted the disk and cleaned up the worker. And now we can see that it's identifying so it selected the demo flavor, which is what we originally intended to do because we created it to match the machine, the source machine. And now it is going to go ahead and create the machine in OpenStack. We can check back to the instances. And we should have it boot anytime soon. There you see, the replica, it was finished after it finished creating the machine and cleaning up any required resources. Now we just have to wait for it to boot. And we have our hello world over here. And we've arrived on our Charmed OpenStack. Thank you for your time.